For the practice 4 worksheet, begin with the SBP weight data. You can see here that I have my SBP weight recode, and over in the columns menu you can see that I have several formulas and some value ordering from different variables that have been recoded or formulas that have been created and saved. So pull up your recoded data and take a look at each of the variables. So we've recoded the race variable, ethnicity, gender, we have age, height, smoking history, smoking current, smoking status, our baseline blood pressure, and our high, yes or no blood pressure at baseline, 48, weight at baseline and month 48 as well. And I'm just going to do an analyze distribution on all of these variables. And very simply take a look. Take a look at the variable, take a look at the proportions, see what you think about each of the variables, and then in your own mind, think about whether or not something would be a predictor or an outcome. So for example, looking at gender, this is generally considered what's called a fixed effect. We ask participants or research participants their gender at the beginning of the study. Now, it can either be sex or gender. Remember that those are two different constructs. They're often used interchangeably. If it's self-report, it's usually gender. If it's biological or clinically confirmed, it's usually sex. So we're talking about gender here. This was a self-reported variable. Most of the time they do overlap, but just be cognizant in your population whether you're asking about self-reported gender or biological sex constructs. So in this case, gender was asked at the beginning of the study. This is a fixed effect. We wouldn't be trying to predict someone's gender. So this is a predictor variable. Gender will likely always be an X variable. Same with ethnicity or race. Those are generally considered fixed or independent factors. They will be what they will be regardless of the outcome variable. So in this study, if you're female, you're likely going to be female in every research that you participate in. So those types of variables, yes, those are generally predictor variables. Thinking about something like age, again, age is usually a predictor unless you are attempting to predict at which age something happens. And in that case, age will become an outcome. Same thing with height, generally a predictor. But if you're particularly working in young adolescent children and you're trying to predict their height, you could see that height would be an outcome there. Smoking history, that can change. So once you've been a smoker, you'll always be at least a past smoker. But you can shift from a never smoker to an ever smoker. So this could be a predictor or an outcome depending upon the question. Same thing with current smoking status. This could change even based on the day. We saw how never and smoking current became this 3-level smoking status. And then we have our SBP baseline, our SBP outcomes, and our weight at baseline and our weight at month 48. So again, SBP could be a predictor or an outcome depending upon the question. Same thing with high blood pressure and the same thing with weight. Because those are variable in that if you measure them on any given day or at any given time, they could be slightly different. They can also be outcomes as well as predictors if you're attempting to predict how someone's weight changes or how their blood pressure changes. But you could also be using weight to predict blood pressure, and you could be using blood pressure to predict the outcome, other outcomes such as stroke. So now that you're familiar with all your variables and you've checked everything for missing and any outliers, you can go back to the practice 4 module. The first part of this worksheet asks you to consider smoking history as a predictor and the outcome is high SBP. So we'll be working with this SMX, this plain smoking history, so ever and ever, and we'll be working with the high SBP variable. So if our predictor is smoking history and our outcome is high systolic blood pressure, yes or no, we're basically looking at a question of, is there a difference in percent with high SBP by smoking history? So there are a number of other ways to ask this question. You could ask if there was a relationship between smoking history and high systolic blood pressure. You could ask, is smoking history associated with high systolic blood pressure? We're not really looking at prediction per se over time yet. We haven't talked about that. This is cross-sectional data, which means these questions were asked at the same time. There'll be more about that in the next module. So we've already identified our predictor as smoking history. So let's address this in our predictor option here. So smoking history is ever, never, right? Those are our levels for a categorical variable. And then our summary of this variable would be n%. And if I wanted to go ahead and do the distribution on both of those for my univariate analysis. So I already had both of these selected in the data set. So when I open up this analyze distribution window, I can simply hit Y columns. We'll do that again so you can see. So if I press the escape key, that will take me out of all of the rows. If I click on smoking history and hold the command or the control key down and click on high SBP, then when I go into analyze distribution, you can see they're both already highlighted, and click on Y and press OK. So these are my univariate analyses. And so I have it for future reference. I can go ahead and say that my evers are 105, and that's 50.7%. And my nevers are 102, so we're almost a 50-50 split here, 49.3% for my ever-nevers. And then for my outcome, it's high SBP. And so again, this is categorical, and I'll be using n% here to summarize. So my outcome is categorical. And my options are high SBP, and there are 43 of those and 17.9%. And then I have normal, and there are 197 of those, and that's 82.1% as we round up here. So that's how we would do our first question. And you can continue on with questions 2 and 3 on your own. Let's jump down here to part 2. So now we're asking to do a fit Y by X for each of the questions that we have above. So we're asking, is there a difference in the percent with high SBP by smoking history? So over here in JMP, we've got the univariate analyses. Now I need my fit Y by X. So I'm going to go to Analyze, Fit Y by X. Remember, smoking history is my X variable, and high SBP is my response, and press OK. And we get our standard fit Y by X for a contingency analysis, contingency table, 2 by 2 table, because I have 2 options here and 2 options here. That's where the 2 by 2 comes from. And if you have an R by C, that means you have more rows than 2 and more columns than 2. So you could have 2 or 3. If I did smoking status with my 3, I would have a 3 by 2 table. So the rows are first and then the columns. We're 2 by 2 here. We can see here in our mosaic plot that our high SBP is represented here. And remember, that was 17.9%. You can see that it's just below the 20% mark right here. And the rest were normal. We can see for our evers and nevers actually that we're pretty straight across. Not a lot of difference in our high and normals just visually. Again, we don't use this plot in publication. We don't turn this plot in. We don't put it in our data briefs. This is not a useful plot. It's a lot of wasted color, but it's helpful for you to assess it visually as you're going in to look at the contingency table. We'll ignore the tests for right now, and we're going to focus here on this contingency table. And we'll take a quick tour here. Our X variable here is smoking, and our Y variable over here is high SBP. We can see that in each of the cells, the top number is our count. So we know that we have 20 people with high blood pressure that have smoked. We know that we have 85 with normal blood pressure that have smoked. We have 19 with high blood pressure that have never smoked. And we have 83 with normal blood pressure that have never smoked. We know that we've got 105 ever smokers and 102 never smokers. And the reason that we know that this is correct is because over here in our worksheet, we'd already collected this information univariately. So I know what to expect. If I saw something other than 105 and 102, I'd know that I have missing data. And speaking of missing data, you can see over here that we have 240 rows in our data set, but we only have 207 paired responses. We only have 207 paired responses. So people that have smoking history and high SBP. So this matches, smoking history matches with our univariate. Let's take a look at our totals for high SBP. In this case, we have 39 people with high SBP. But wait a second, over here, I have 43 people with high SBP. And I have 197 with normal. And over here, I only have 168. That means that our smoking history was our limiting status here. We have fewer people that have answered the smoking history questions than have answered the SBP questions. And that's okay. We need to just make sure to note that if we're talking about this data set of 240, that we only have 207 responses for this particular fit Y by X. And that's completely permissible. If you have missing data, simply report that you have missing data. From here, we can take a look at the different percentages. The top percent will be the total percent. That's this 20 out of 207. 20 out of 207. So this is when you're saying and. We have 9.7% of respondents from our 207 who have both high blood pressure and have smoked in the past. That's an and situation. So that's out of your total sample size. It's relatively rare that we're reporting the total sample size. We are most commonly reporting row percentages. So we'll go through column percentages first, and then we'll focus on the row percents. The column percentage means that you are conditioning on the column. So I am picking the column first, and then I'm going to report the percent with each row. So I'm conditioning on the column. So my denominator here will be 39. I'm conditioning on high blood pressure. If I wanted to use column percents, I would say out of those with high blood pressure, 51.3% have smoked in the past, and 48.7% have not smoked in the past. So out of those with high blood pressure, these are our percentages. So it's out of the column. These will add up to 100% within this column. Same thing over here, 50.6 and 49.4 will add up to 100%. We are within this normal column. More often than not, we're reporting row percentages because we want to look at high blood pressure by smoking status. We're going to condition on the smoking status first. So by ever smokers, so for ever smokers or out of ever smokers, out of these 105, I've got 19.1% with high blood pressure. 19.1% with high blood pressure. And out of the never smokers, I have 18.6% high blood pressure. So we can look again, if we wanted to look at normal, 80.95 of evers have normal blood pressure, 81% actually, and 81.4% of the nevers have normal blood pressure. In this case, you'll notice that these add to 100%. So when you're in row percentages, you'll add to 100% across the row. When you're in column percentages, you'll add to 100% down the column. And when you're looking at total percentages, you'll take the total N, right? That's your 207. These percentages will add up to 100. So your total percents. We are almost always going to report row percents. So for this very first question here in our practice module, we have 19.1% of the ever smokers have high blood pressure and 18.6% of the nevers. Those are roughly similar. They're less than 0.5%. So you could go with greater than, but I would actually say that these have similar. So we are similar, are observed to be similar to the proportion of those that have never smoked. And we can go ahead and put our N's and percents in from this table. So 20 who have smoked, and there are 19.1% of those, and of those versus who have never smoked, and there are 19 and 18.6% of those. Now we may want to go ahead here and put total N equals 207 because it is less than our total 240 N if we were reporting in a paper. So that is how you're going to address these questions. That's how you're going to address these questions. Continue on with questions 2 and 3.